Good morning, guys. I'm going to do a quick lesson on division for you. We are looking at division in the next couple of lessons. So, a little recap of basically what division is and how we can apply it to 5th grade learning. So, you should already know that division is separating a value into equal groups. We should have learned this in 2nd, 3rd, and 4th grade. So you can see if this was my value and these were my groups, you see there are 4 equal groups. So it's essentially something divided by 4 equals something. So let's think about it like this. If I said this was 20, then 20 divided by 4 would equal something. I don't really know exactly what that is. So if I were to use the 2nd grade, 3rd grade methods, I might say, oh, okay, well, let me just put 1 into each of those groups until I've got 20. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then I go, oh, okay, wait, I reached 20. Then I just need to think how many are in each of these groups. Well, there are 5 in this one, there are 5 in this one, 5 here, and 5 here as well. So that means each group has an equal amount, and that answer is 5. That is how division should have been introduced to you initially. One of the things I want you to understand about division is simply the opposite of multiplication. So you'll be able to see here 3 times 5 equals 15. If we were to flip that around and say 15 divided by 5, we would end up with 3. So you can see how these numbers kind of appear again in just opposite order. We usually call these fact families. And for some reason, we're really big on fact families when it comes to addition and subtraction, but we don't really think about it in terms of multiplication and division quite enough. If you really look through this, you can see in each of these fact families, I'm multiplying by 5. So if I was to continue, I would say 4 times 5 equals 20, just like 20 divided by 5 equals 4. 5 times 5 equals 25. Just like 25 divided by 5 equals 5. 6 times 5 equals 30. Just like 30 divided by 5 equals 6. 7 times 5 equals 35. Just like 35 divided by 5 equals 7. So what I'd like you to do, just really quickly, thinking about how division is just the opposite of multiplication, I want you to take a look at these 8s, and if you need to pause the video, go ahead and pause for a minute and see if we can figure out what the answer would be if we started with 6, 7, 8, and 9. Think about it in terms of multiplication, and then tell me what answer you come up with. You should have realized that 6 times 8 is 48. You should have realized that 7 times 8 is 56. 8 times 8 would be 64. And 9 times 8 would be 72. If you know these basic facts, you should be able to see them when you're dividing. So let's think about this as the opposite, the fact family version of it. If this is the multiplication, how would we set it up for the division? Well, we would simply say, since 6 times 8 is 48, 48 divided by 8 must be 6. Since 7 times 8 is 56, 56 divided by 8 equals 7. Since 8 times 8 equals 64, 64 divided by 8 equals 8. And since 9 times 8 equals 72, 72 divided by 8 should equal 9. Now, one of the words you're going to hear in math for basically your middle school years and high school years is you're going to hear the term inverse operation. Inverse operation is a mathematical term that simply means opposite. So, multiplication is the inverse operation of division, and division is the inverse operation of multiplication. So for those of you that are thinking division's really, really hard, don't freak out. Just remember your basic facts in multiplication and look for those when you're doing the division. I'm going to show you how you can make that happen. And I just realized I left the R off of the word operation. Way to go, Mr. Ellis. See, this is why I miss you guys in the classroom. You let me know when I make bonehead mistakes like this. So yeah, inverse operation. So let's think about long division. That's that division that everybody is assigned and they think, it takes forever and it's so frustrating, it's so hard to do. But when you think about it, long division is basically just basic division over and over again. So my advice to you is just start with what you already know. You already know your multiplication facts. So don't be afraid to use those when you're doing some division. Use those inverse operations, and yes, I did remember the R that time, inverse operations and your basic facts. Let's look at a couple of examples. I've got a couple of examples here that I'm going to show you how you can use the basic facts to really help you out. Let's focus on just this one first. And to make it easy on us, I went ahead and already prepared the basic facts for my 8s. So I've got my multiples of 8 listed here, all the way through the 12th multiple, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, and 96. Basically what we need to think is, can we just simply fit any of these multiples into this number? Do they appear there? Well, let's think. 76, no, 76 isn't on here. 80 is too big, but 72 would fit into 76. So let's just think. 8 times what makes 72? 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 times 9 makes 72. So we know that in this 76, we can fit 9 groups of 8. That would be 72. So we just remove that. 76 minus 72 is going to give me 4. Then I just need to think, can I fit this 8 in, and can I get 8 to go into 48? Well, let's look at those multiples again. Does 48 appear anywhere? And in fact, it does. So 48 is the 6th multiple of 8. So we know that 8 will go into 48 6 times. 48 minus 48 is going to be 0. And when we have no remainder, we know that our quotient is just a whole number. So 8 goes into 768 96 times. Let's look at this next example. We've got 5 going into 360. Again, I went ahead and prepared the multiples of 5 because it's really important to remember that long division really is just inverse operation of multiplication. So use the multiplication that you know. 5 going into 36. Well, I can't fit 5 into 3. That's just not going to work. So can I fit 5 into 36? I don't see 36 anywhere here. And I know 40 is too large. So I'm going to have to use 35. Well, how many times will I have to multiply 5 to get 35? 1, 2, 3, 4, 5, 6, 7. Oh yeah, 7 times 5 makes 35. So I know that this 5 will go into 36 7 times. That will give me 35. When I take that out, I'm left with 1. If I bring down this 0, it gives me a 10. And I simply just need to repeat the process. Will 5 go into 10? When I look at my list of multiples, hey, sure enough, there's 10 right there. 5 will go into 10 2 times. And I know that 5 times 2 is 10, so when I take that 10 out, I'm left with no remainder. That lets me know that my quotient is a whole number. So 5 goes into 360 72 times. This is a neat little way of just using the multiples I know to help me get the quotients I need in basic long division.